Hello! Today in this video, I'm going to be talking about Ohm's law. Ohm's law contains three different components: voltage, current, and resistance. These are denoted by V, I, and R. First, we're going to talk about current. Current is the amount of charge that passes through a given point in an amount of time. Current is made up of charges, normally negatively charged electrons or positively charged protons that flow from one place to another along some type of wire. This is denoted by the equation I equals Q over T. Let's think of this in terms of ants. Ants are a good way to imagine this because each ant is individual, yet they tend to follow together in a line. Likewise, charges are often trapped within a wire, causing them to form a fairly linear shape. If we say that each ant is a charge, which is denoted by Q, then we can measure the current of the ants by counting how many cross this line in a given amount of time to measure the speed of the current. For instance, if 10 ants cross the line in 2 seconds, we can see that 10 ants divided by 2 seconds is 5. The unit for current is an ampere, or an amp. This is denoted by the capital letter A. Current flows from positive to negative, or in other words, it moves in the direction that a positive charge would flow. If we say that the ants heading toward the anthill are positive charges, then the current would be moving in this direction. However, if ants leaving the anthill are negative charges, then they are moving in the opposite direction of the current flow. To calculate the current in this situation, we would have to discover the net amount of ants that cross the line going toward the anthill. So let's say that 10 ants go across the line toward the anthill in 2 seconds, but 4 go across the line away from the anthill in those 2 seconds. Heading away from the anthill, we have 4 ants in 2 seconds with a current of 2. Then, heading toward the anthill, we have 10 ants in 2 seconds with a current of 5. Total current is the sum of positive and negative current, so the current toward and away. Therefore, the current is 5 minus 2, so the answer would be 3 amperes. Now let's talk about resistance. Resistance is caused by some sort of resistor that constricts the current in some way. This causes less charges to be able to cross the line in the same amount of time, so it causes a smaller current after the resistor. Let's imagine a resistor like we would the top of an anthill. There's a small opening allowing only a few ants through at a time. If normally when walking along, the ants can get about 10 ants through in 2 seconds for a current of 5, like we had discussed earlier, when they approach the anthill, only 2 can go through at a time. Then the anthill would be a resistor of 2. No matter how many ants you bring to the top of the anthill, only 2 can go through at a time. So the current after the anthill is slowed down to 2 ants per second, or 2 amperes. Before the anthill, the current was 5 amperes. After, the current was 2 amperes. That change in current across a specific place is called a resistor. This causes resistance in a system. Something about that red box altered the current. Resistance in a real system works similarly. It inhibits the amount of charge that can go through by providing a small tunnel to go through. Notice there are fewer ants after the resistor. As we will learn, resistance is related to voltage and current, and its job is to alter current. This is useful in real life because it allows us to control the voltage and current in a circuit system. This stops the system from overheating. If the current going through your house is too fast, it creates a lot of energy. When there is no other way to get rid of it, the system overheats. This can cause a fire. Resistors slow it down, lowering the risk of overheating. Because resistance controls the amount of current, it ensures that a more constant amount of current is coming at a time. This lets us control how much energy is being given to household appliances, like for instance a blow dryer. A weak stream is much more common. You don't want it to be too much or else you can get hurt. Resistance is measured in ohms, hence the name Ohm's law. This is denoted by the Greek symbol for ohm. Finally, let's discuss voltage. Voltage is an interesting topic to define. In basic terms, voltage is a potential difference. A potential difference is when there are more charges in one place than in another. This causes the charges to choose, if you will, to move to a new place, and in this way keep the flow going. In this way, voltage is the drive behind why charges move through a circuit. Let's see this again with ants. There are 120 ants in the anthill and 0 ants outside. That means there is a 120 volt, or ant, potential difference. There are 120 ants in one place and 0 in another, so the difference is 120. That is the overall voltage of the system, because that is exactly how many ants, or charges, are possible to move around. However, we know that it is very rare for every ant to be inside the anthill, which is, in this scenario, represents a power source, like a battery. Out in the real world, the ants are following along each other in a line, but when they reach a resistor, it may slow down their current or speed. If we have 8 ants on the outside and 2 on the inside, then the potential difference would be 6. Because of this, if we have a resistance, fewer ants would be allowed through the resistor than would normally go through the wire. So we have a potential difference across the resistor, or a change in voltage caused by a resistor. Voltage is measured in volts. This is denoted by the capital letter V. Let's put all of this together. Ohm's law states that V equals IR. This can be maneuvered in many ways, such as I equals V over R, or R equals V over I. Ultimately, the purpose of Ohm's law is to understand the way that charges are moving around in a circuit. If we know the amount of ants in a system, how fast they are moving, and any obstacles in their way, or voltage, current, and resistance, we can understand the circuit and how it would be charged. Likewise, if we know just 2 of those things, we can calculate the other. Back to ants. For instance, if we know that we have a current of 5 ants in 1 second, that would be a current of 5 amperes. If 2 ants can go through a resistor in a second, then we have a resistance of 2. Knowing these things, we can calculate the voltage using V equals I times R. So, 5 amperes times 2 ohms equals 10 volts.